So the next big topic that we cover in this class is what we call unit circle trigonometry. So the first thing that we need to sort of define is what is a unit circle, and that part is easy. A unit circle is just a circle with radius 1. So a circle with a radius of 1. That's what we call a unit circle. So the big thing that we've got to kind of wrap our heads around here in the beginning is, how do the points on this circle relate to the trig functions? So let's start with just a point somewhere on this circle. I'll say right here. So we got a point. We'll just keep it, keep it general. So I'm going to say this point is x, y. So what I want to be able to do is, I want to be able to relate everything I'm doing on here to the trig definitions that we looked at with the right triangles. So here's what I'm going to do. I'm going to create a right triangle sort of inside this circle here. Because in math, anytime we learn something new, it's always helpful to relate it back to what we've already learned. So, don't know exactly what this angle is right here. I'm just going to call it theta. Alright, so let's work with this, what we've got right here. I've got my unit circle, a point on that circle I've labeled x and y. I'm going to keep it as general as possible. And I've got this angle theta. So first thing we need to do is we need to use what we know about this circle. We know that this is a unit circle, so the radius is assumed to be 1. Well, if the radius of the circle is 1, then I actually know this hypotenuse length. So the hypotenuse of this right triangle that I've created is 1, because the hypotenuse is the same thing as the radius of the circle. So the hypotenuse is 1. So let's see what else we know about this right triangle. So let's see if we can figure out these other two lengths of the triangle. And to do that, I'm going to use this point. So if I know this point is xy, I know this distance on the bottom is x. And I also know that the distance up from here to here has to be y. Because think about what you would do to plot, a general point like xy. You start at the origin and you go over x units and up y units. I mean, that's how plotting points works. If this point were, 3, 5, I go over 1, 2, 3, up 1, 2, 3, 4, 5. So if this point is x, y, then the distance here is x, and the distance up here is y. So now that we know that, now that we've got this right triangle labeled, let's play around with the definitions of, cosine and sine that we already know. So let's start with sine. Remember from SOHCAHTOA that the definition of sine is opposite over hypotenuse. So for this angle right here, my opposite side is y, and my hypotenuse is 1. So sine of theta is equal to y over 1. So y over 1, that simplifies to y. So sine of theta equals y. We just got our first sort of result from the unit circle. So the definition of sine in the unit circle is actually just the y-coordinate of the point on the unit circle. So let's do the same thing for cosine of theta. Again, I'm going to use the definitions that we've already learned. So the cosine of theta is equal to the adjacent side over the hypotenuse. So adjacent over hypotenuse. So x over 1. So x over 1, we can simplify that the same sort of way. X over 1 is just x. So cosine of theta equals just x in this case. Well, in every case on the unit circle to be exact. So sine of theta equals y, cosine of theta equals x. So what about tangent? Let's see if we can figure out tangent. Tangent of theta equals, again, I'm just going to use the definition that we've already learned for tangent. So tangent of theta is defined as the opposite side over the adjacent side. So y over x. So y over x. Obviously not anything we can simplify here, but we've still got our result here. Tangent of theta equals y over x. So, just to recap, here's what we know. If we've got an angle and a point on this unit circle, from that point, from that x and y coordinate, we can evaluate all three trig functions. Sine of theta is equal to the y coordinate of the point. Cosine of theta is equal to the x coordinate of the point. Tangent of theta is equal to y divided by x. So from these two numbers in the point, we can calculate all three of the trig functions.